Today, we are going through one of the few topics that majority of students dislike, which is about proof of circle theorems. Now, many students will even have trouble remembering all the circle theorems, let alone proving them, right? So, if you like maths and want to continue to study maths in A level or uni or any higher level of education, then you must learn to enjoy proofs and make proofs one of your best friends. Because maths in a really high level at the end is all about proving logically. I remember talking about the difference between theorem and theories. If you don't remember them or haven't watched them, haven't heard of them before, you can go back to the Pythagoras video, which I explain the difference between theorem and theory. Maths is always about theorems. Okay. Anyway, I remember very vividly when I did my maths degree in uni. There was a lecturer. If I remember correctly, his name is Professor Coolen. Might be wrong. He made lots of interesting quotes. I am going to share one with you at the end of each proof. Okay. So this lesson will contain no example of practice.
What?
Because if you want to practice, you can just pause the video and have a go again yourself. With an empty diagram, you can have a go on a separate paper.
Look, if you guys don't stop right now, there will be consequences.
Okay, so all I can do is just show you the proof. Okay, so before diving into the proof, let's recap on all the circle theorems first. So the first circle theorem, I named them 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to use this 1 to 8, which is also the same order as the circle theorem video in grade 6. So theorem 1, angle at the center is twice the angle at circumference. So the way you remember it, this is the arrowhead. I'll just quickly draw a quick one. It's like this. Remember that? The arrowhead, this is twice the angle of that one, so that's the arrow. Second one, the angle is semicircle's right angle. A semicircle like this, something like this, that's a right angle. And then angles subtended at a circumference by the same arc are equal, so that's the butterfly one. Call it butterfly because you have to use a bit of imagination. Imagine that's your head, and that's the wings. Anyway, opposite angles in a cyclic quadrilateral add up to 180 degree. So cyclic quadrilateral means it's a quadrilateral inside a circle. The opposite angle add up to 180 degree. Alternate segment theorem is a set with a hook, so it's a tangent, and then with that one, so it's that one, that one. Why is it set with a hook? That's set and a hook in there. Number 6, the perpendicular from a center of circle and a chord bisects. The chord, nothing I can remind you, something like this. So that's bisect the chord. Now, great theorem number 7, tangent and radius makes a right angle. It's there. I just cross out because we're not going to prove it. You don't have to learn how to prove number 7. Okay, so we'll take it out of the equation today. Theorem 8, tangents drawn to a circle from a point outside a circle are equal in length. So we're saying these two lines will be equal in length. These two lines will be equal in length. So just a quick recap on them. Okay. In the notes, I've also provided you the summary of the proof of each circle theorem, just to give you some sort of quick tip on how to remember what are the steps in between. Okay, so I'm going to show you step by step, and I'm going to refer to this summary at the end of each proof.
Promise you'll never leave me?
So theorem number 1, let's dive in. Now, as I said, if you want to practice this question, you can just pause the video, easily pause the video, and just get a paper out, and using this diagram, just do it again yourself. Okay, the question will just be proof theorem 1, proof angle at the center is twice the angle of circumference. It is literally as it is. So let's dive in. Okay, so to begin with, the aim is to prove the angle AOC is double the angle of ABC. So we're trying to prove this angle is double of that one. Now the first step we're going to do is we're going to use a ruler and join up the point O to B. So we're going to split the arrow into 2 triangles. Okay, so one is AOB and one is OBC. Next step, we're going to let ABO as X. So we're going to let the angle ABO equals X. Now with proof, it's almost like you are writing a cookbook or writing some instructions. You must lay down step by step what you're trying to do and explain or sort of explain to people, to dummies, or why are you doing this? Why do you take from step 1 to step 2, etc. Okay, so we let ABO equals X. Okay, we'll go also let angle OBC equals Y. So begin with, so let that one. Okay, next, so I'm going to use different color for step 2. Next, what do we know about ON, OB, and OC? Now, these lines from the center to circumference are known as the radii, plural for radius. So what we know is because OA equals AB, their radius, okay? So therefore, the angle OAB will equal the angle of OBA. So OAB, this angle, will be the same as the top one, which is X. Reason being is isosceles triangle. Okay, so if we know that's X, what else do we have to find? Well, then we can work out that one, don't we? The AOB. So angle. Now, this means because, therefore, it implies angle AOB equals 180 degree minus 2x. Because sum of triangle is 180 degrees, so you can say angles in a triangle. Now you're allowed to use these notations in the exam. This means angles triangle, so you're allowed to use these notations. Okay, so we know AOB is 180 degree minus 2x. Right, next we'll go do the same on the right side. Okay, because OB is same as OC, it's a radius again. So therefore, angle OCB equals angle OBC equals y, isosceles triangle, and which implies angle BOC equals 180 degree minus 2y. Now you don't have to use all the these symbols correctly really on the left hand side, but if you can follow, that would be the best. Okay, so we know this is going to be 180 degree minus 2y because that's y 180 degree minus 2y. Next, so what else do we find? Remember that our aim is to prove AOC equals double of that. So we have to work out the angle of AOC. So last but not least, I'm going to use here. So therefore, angle AOC, angle AOC equals 360 degree minus the 180 degree minus 2x, subtract the bracket 180 degree minus 2y. Reason, angles at a point. Angles at a point every 360. So to work out this angle AOC in here, we can do 360 minus 2 angles. One thing you have to note is you must put a bracket when you subtract them, because the minus will change the sign inside bracket. 360 take away 180, take away 180, it's gone. Okay, minus minus makes a plus, so it'll be a positive 2x. Minus minus makes a plus, it'll be 2y. So that is the same as 2 bracket x plus y, which is the same as 2 times the angle of ABC, which is that one here. So therefore, we've proven it. So you can see we've proven AOC equals 2 times ABC, and that's the answer. To help you remember this proof, so the summary is you split the arrow into 2, like we did, okay? And then we're going to use isosceles triangles, because we're using it on the left hand side and the right hand side. And then we use angles at a point. So it sort of sums up everything, sort of the big steps you're doing in here. Now you can also use mnemonics. If you don't know what mnemonics means, mnemonics is a memory strategy to help you remember a couple of items. Mnemonics uses the initial letter of some keywords to string a word. Whether the word makes sense or not, it doesn't make a difference. For example, for theorem 1, you can remember as S and then I and then A. Or if you don't like to use the word A, you can use point, because point probably means more than the word angle. So this becomes the word SIP, S-I-P. So if you remember theorem 1, SIP, S means split, isosceles triangle, and a point. So that's how you can remember theorem 1. All right. And the quote for this one is his word, not mine. If you don't know it, you will struggle. I know it sounds nonsense, but in a high level, it is very true. And even in this proof, it is true as well. If you don't know it, you will struggle. Next one, theorem number 2. Angle in a semicircle is a right angle. So what we're trying to prove is we're trying to prove the angle ABC is a right angle in there. Now I'm going to rub it off because I don't want to confuse you for assuming there's a right angle. We're trying to prove it. Yes, we know it's a right angle, but we're trying to prove it. So first step, we're going to do the same. We're going to split into two. Okay, split a triangle into two more triangles. Next, we're going to let the angle OAB equals x. So angle OAB is x. Next, actually that x is quite ugly, so I'm going to write again. Now, what do we know? We use the radius trick again. So we know because OA equals OB, which is about radius. Okay, so therefore the angle OAB equals angle OBA. So that will equals x as well. So that's the first step. Next, in a triangle, what else have we not used yet? We haven't used that angle. So, which implies angle AOB equals 180 degree minus 2x. Angles in a triangle, 180 degree minus 2x. That's 180 degree minus 2x. Now, then we haven't used this other triangle yet, so we're going to do the same. So 180 degree minus 2x. Now we know angles on a straight line will end up 180 degree. So therefore, the angle BOC must be 2x. So therefore, it implies angle BOC equals 2x because angles on a straight line. So angles on a straight line is 180 degree. So 180 degree minus 2x plus something is 180 degree. That angle must be 2x because if we try to add these two up, that will be 180 degree. Right, so we know that's 2x. What's next? We're going to continue to work out all the angles. So we're going to go and work out these two angles. Now we know because OB equals OC is radius again, they're both radii. So therefore, the angle OBC will equal to the angle OCB. And what would they equal to? They will equal to 180 degree minus 2x divided by 2. Which is, if you halve each number, will be 90 degree minus x. And the reason being is angles in a triangle. So each of them equals 90 degree minus x. So remember, all we need to prove is the angle ABC add up to 180 degree. So we can do that. So now, once we know that ABO is x and OBC is 90 minus x, therefore, the angle ABC equals the angle of ABO plus the angle OBC, which is x plus 90 degree minus x. If you simplify the algebra, you get 90 degree. Proven. All right. So what's the summary then? So how do you remember this? So theorem 2, to help you remember it, you can again start with the word S. Okay, split into triangle into two. Again, isosceles triangle, and this time you can say, I don't know, this one you can say add or something. So split in triangle, isosceles, and add them up. So SIA, perhaps. So what's the quote? What's the words of wisdom for this theorem? Well, what he said, okay, Professor Cullen, not doctor, sorry, Professor Cullen said, if you know it, you know it. That's it. You know, small words, but big meaning. If you know it, you know it. Next one, theorem number 3, angles subtended at a circumference by the same arc are equal. So first step, you're going to connect to the center again. Okay, so you're going to connect to the center like this. Okay, next one, you can let the angle AOD equals 2x. So AOD equals 2x. The angle is x. Next, now using theorem 1, we know the angle at the circumference is half the angle center, or angle at center is twice the angle circumference, like an arrowhead, basically, like that one. Hopefully you do remember what, sorry for the poor highlighting, but hopefully you do see what I mean. it's like this. Remember that one. So if that's x, that will be 2x a bit luckily, but you get what I mean. So therefore, okay, what it means is the angle ABD, this one, will be half of angle AOD, which is a half x. Next, you could do the same. Now you have got different arrow this time. This arrowhead is the same thing. So angle ACD is also, oh, actually, you have to explain the reason in here. The reason because angles, you can use a notation. Angles at center is twice angles at circumference. Okay, so angle ACD will be the same thing. So angle ACD also equals to a half of angle AOD because of the arrowhead, which is also half x. Reason, angles at center is twice. Yes, it's a bit tedious, but you do have to write out because even the same meaning, you cannot just skip it because people have no idea where did it come from. Okay, so you have to explain to dummies why they're the same. Why ACD is half of AOD, because angles at center is twice the angle at circumference. Right? So therefore, what it means is therefore angle ABD equals the angle ACD, which they're both equal to half x, and therefore we're done. We've proven both of these angle ABD is same as the angle ACD. Sorry if I didn't give you the aim in here, I'm sorry. So the aim is to prove the angle ABD is same as the angle ACD. Alright? Okay. So how do you remember this? To remember this, theorem 3, what you can do is you can remember we're connecting to the center, and then now this bit you can use your own creativity on how you want to remember it. I personally remember is AAC twice means 2, so I use C and then AAC 2. It sounds a bit off like CAC 2, but you know, it doesn't matter how you remember it. That as I said, you can use your own creativity to remember how you want to remember it. Okay, right. What about the quote for this time? The quote, the wisdom words from our Professor Cullen is, "Once you know it, it is easy to show." I'll leave you for interpretation. Theorem number 4. When you prove the opposite angles in a cyclic quadrilateral add up to 180 degrees. So, in other words, we're trying to prove the angle BAD, the bad angle, plus the angle BCD is 108, add them up to 180 degrees. Again, we need algebra. So, to begin with, same thing, we connect to the center. Okay, so connect the B and D, this time B to D, to the center, not the angles involved in the center. Next, so we're going to let the angle BCD equals x. So we let that to be x, and we let the angle, the bottom angle, BAD, bad angle, to be y. Don't ask why. The bad angle is just y. All right. Next, we use the arrowhead again. So how do we use it this time? Look at that one. Theorem 1. So what can we tell? We can tell the angle underneath here will be double of x. So the angle BOD will equals to 2 times the angle of BCD, which is 2x. Reason, angle at the center is twice the angle at circumference. Right? So that's 2x. We apply the same trick, but this time to the other end, using the y end. So if we think about the y end, same thing in here. You can see the arrowhead this time, but this time it's a reverse arrowhead. We can see if that's y, this will be 2y. But now, how do you label that as 2y? Because they're both at BOD, so that's not the same as BOD in here. Now, if you want to call the reflex angle, you just have to put angle BOD bracket reflex. Then people will know we talk about the reflex angle of angle BOD equals 2 times the angle of BAD, which is 2y. Reason, angle at the center is twice the angle at the circumference. Handwriting is just the same as my patience. It's getting worse and worse as I write this so many times. It's like the same kid asking the same question every single lesson. You lose your patience.
Are we there yet?
No.
Are we there yet?
Not yet.
Hey, are we there yet?
No.
Are we there yet?
No.
Are we there yet?
Yes.
Really?
No.
Are we there yet?
No.
Are we there yet?
No, we are not.
Are we there yet?
No.
All right, I get it. I'm just so darn bored.
Well, find a way to entertain yourself.
Anyway, so I hope you understand what I try and write in here. Angle center is twice the angle circumference. So what do we have in here? Now, what do we know about the center of circle in a point? So at the center of a point, we know, which implies the 2x plus 2y equals 360 degree. Reason being, angles at a point. Okay. See, the handwriting is slightly better than that one because it's a different reason. So I get a bit of patience of writing it. I get a bit of enjoyment. Enjoyment writing reasoning, maybe. I teach maths. I'm a geek. Why am I? Right. So 2x plus 2y equals 360. What's next then? If that's 2x plus 2y is 360, we can factorize the 2 out. So 2 bracket x plus y equals 360 degree. Divide by 2, x plus y equals 180 degree. So we've shown x plus y is 180 degrees. So the angle BAD and angle BCD does add up to 180 degree. So we can write therefore angle BAD plus angle BCD equals 180 degree. And that's the end of proof. All right. So how do you remember this? To remember this, you can use same letter. C means connect to center. And then I use AAC because angle at center, and then twice 2 again. So same reason as 3. Okay, even though how we apply it is slightly different, but essentially, you can remember the same thing. CAAC 2. And the quote this time is, once you see it, you will know it. Yes, as simple as this. Yes, once you see it, you will know it. Theorem number 5. Alternate segment theorem. Theorem. We have to prove the angle BAC is the same as the angle CDA. So we try to prove these two angles are the same. Okay. Right. Now, next, what we're going to do is we're going to connect to the center. Now, one thing you have to remember how to connect to the center is we are going to connect this point and that point. We'll try to show these two angles. If you're using that one and that one instead, if you're using EAD and DCA, then you should be connecting this triangle to that side instead. Okay, so I guess that's one thing you have to remember. Right, next we're gonna let the angle BAC, one of the angle that we'll try to prove as x. So that's it, x. What else do we know? We know OA is a radius, B is a tangent. So therefore, angle OAB is a 90 degree because radius and tangent makes a right angle. Makes a 90 degree. Makes a right angle. Makes right angle. So I can use this symbol. So right angle is an angle with a right angle is in a square. So that's the right angle. Now if that's a right angle, what do we know about the angle OAC? This little gap angle will be 90 minus x. So therefore the angle OAC equals 90 degree minus x. So this is 90 degree minus x. Right, then you've been here a few times already. Inside triangle with a center of circle as one of the lengths, you're using the isosceles triangle again. So it's different color. So because OC equals OA radius, therefore angle OCA also equals the angle OAC, which is 90 degree minus x. Isosceles triangle. So that's 90 degree minus x as well. And what do we know about angle COA? So angle COA is going to be 180 degree. Subtract 90 degree minus x. Subtract 90 degree minus x. Which is, so 180 minus 90 is 0. Minus a plus, minus a plus. That leaves us with 2x. So angle COA is 2x. So if we know angle COX is 2x, we can use the arrowhead again in here. So therefore, angle CDA equals to half of the angle COA, which is a half times 2x, which is x. The reason being is, again, angle at the center is twice the angle at circumference. Clearly it means circumference, like doctors writing paracetamol. Have you seen how doctors write paracetamol? I'll show you a picture in here. Right, so if that's x, then we've proven, because we've proven, you see angle BAC is now equal to angle CDA, which equals to x. So we've proven. All right, so how do you remember this? To remember this, you can use the word again, C, connect to center. Okay, now this time what I use is, I believe, let me check my notes. I believe I used, 90, and then isosceles triangle, and then angle at center. So this will be a bit longer. C, and then 90, and then isosceles AAC. Now, is there a way you can remember it better? Use your imagination, use anything you want to, okay? But the order, you can choose different letters, but the order cannot change, because if you change the order of letters, it will change the order of your working out, okay? If you don't like to use this, you don't have to remember this, all right? And what's the quote from our Professor Cullen? So next one he said is, if you don't know, you can stare at it for an hour and you're still stuck with it. Are you still here with me? If you are, thank you. Okay, so I hope you are enjoying all the quotes that our dearest professor sharing with us. Anyway, theorem number 6: the perpendicular from a center of circle to a chord bisects the chord. Bisects means cut into half. It's like Fruit Ninja, you're cutting into half. Right, so what we're trying to do is we're trying to show AM equals MB. So where's M then? This is the point M. You have to make it on your own. You have to make it. Sometimes you have to make it. Sometimes provided, but sometimes you have to make it. So M is midpoint. Meant to be the midpoint. So you have to show AM is the same as MB. Now to do this, you're going to use congruency to help you show it. So first thing, you're going to connect to the center again. So connect to the center, make a triangle. Okay. Next, you're going to use the RHS in a congruency to prove they are congruent, and therefore AM will be the same as MB. So this is how it goes. To prove RHS, okay, we'll use RHS. R stands for right angle. So you have to say angle OMA equals angle OMB equals 90 degree. Well, clearly, because if that's 90, that will also be 90 as well. You can write angles on a straight line, I guess. Next, so that's the R. We've done the R. H, hypotenuse. So because OA, same as OB, radius, we have said this because always same as OB, so we've proven they are equal again. So hypotenuse sorted. S means a side. You can't use AM and MB because that's the whole point of the proof. We use OM, and because OM is shared, therefore triangle OMA is congruent. Now this is symbol for congruency, so it means congruent to triangle OMB. And what it implies is, therefore, implies AM equals MB. That's our A, and we've proven it. Okay, sort of somewhat easier than the other. So to remember this, start off with, again, connect to center, C, and then use RHS to show congruency. Now I don't know how you want to use this. I just use C, means congruent, CC, congruent. You can see RHS, up to you. Okay, I use CC. So, quote. The quote is, if you know it, it's 1 minute. Yeah, that's it. That's what he told us in the revision lecture before we had our exam a week beforehand. If you know it, it's 1 minute. Last theorem. Okay. Remember, we're skipping theorem number 7 because we don't have to prove it. Theorem number 8. Tangents drawn to a circle from a point outside a circle are equal in length. In other words, we'll try to prove AB is same as length of BC. To prove of any length, we're going to use the congruency to help us. But before we do that, we first have to connect to center of circle again. Okay, so point A, that one. Right, what we also need to do is also need to divide that into half. So these are the sort of preparatory work. First step, you will say angle OAB equals angle OCB. So these two, what do we know about these two angles? Hopefully you remember the circle theorem, the equals 90 degree. Okay, the reason being is radius and tangent make 90 degree, make a right angle. Okay, so what else do we know? So we've proven, okay, again we use RHS to prove congruency. We've proven right angle. Next, hypotenuse. Where is the hypotenuse? Hypotenuse is the length opposite the right angle, which is this length. So same thing, we can say OB is shared. Okay, no reason. OB is shared. What else? RH, so we've done H. Next one, S side. You can't use AB and BC, so all we can use is OA and OC. Well, clearly they're equal because of radius. So OA equals OC because they're both radius. Radii, sorry. So therefore, triangle OAB is congruent to triangle OCB. And the reason is RHS. Yeah, I provide reason for the last one. I did not. I should put RHS in there. Sorry. So if they're RHS, therefore, the length AB equals BC. And that's the answer. Okay, that's the proof. So how do you remember this? Well, again, connect to center, but this time you also have to split. So, and then you can use the tangent radius equals 90 degree, and then use congruency. So for this one, I use C as 90 and C. All right. I've said many times, use your own imagination. All right. I've used up all the quotes that insightful Professor Cullen has given to me, so I'm going to repeat them in the last theorem. The first one, if you don't know it, you will struggle. If you know it, you will know it. Once you know, it's easy to show. Once you see it, you will know. If you don't know it, you can stare at it for an hour and still stuck with it. And the last one, if you know it, it is 1 minute. Thank you.